Hi and welcome to my video presentation for the Changemakers module. My name is Martin Pugsley and I'm a data analyst at the DVLA. So the role I'm currently in is evolving slowly into a data scientist role. So this project has been a good opportunity to learn and apply data science techniques into an experimental prototype model. So my project idea is to create an automated prediction model for incoming daily receipts at the DVLA. The model will take into account seasonality for weeks, such as discovering days which tend to get more volume in certain types of receipts, and also discover trends of the monthly receipts. For example, Christmas periods tend to get lower volumes than summer periods. This model will learn and then give predictions based on real-life information. It's down to COVID my ideas come about, because one of my daily tasks is to monitor the work backlogs throughout the agency. So I can see they have risen significantly due to the reduced number of staff being able to work, and this is down to old legacy systems having security issues that don't allow home working and social distancing rules within the building. So it's because of this I have to start thinking proactively of how DVLA can reduce its backlogs now that things are starting to return to normal. My first thought was, if I can predict what work is coming to DVLA, we can allocate resources better and share casework and staff across operational areas. As I know through experience, some areas are overstaffed on certain days because the work has run out. If I can predict these days, it will be possible to deploy additional staff to these areas that are more busy, and we can reduce the backlogs here, meaning that customers have reduced waiting times on their transactions. There are other numerous objectives of this project, and not just to reduce backlogs and improve customer waiting times, but DVLA is notorious for employing seasonal temporary staff to deal with high backlog times. This can be reduced or potentially avoided by using the staff resource we already have, but the first step is predicting the receipts accurately so resources can be shared, and doing this we will reduce funding spent by the DVLA, meaning that taxpayer money is saved, which is always a good thing. These funds can then be allocated to other projects that could potentially do something similar in the future. So as I mentioned, it is an experimental prototype, which is what data science is really about. Trying different things with data and then trying these things in real life practices. This prototype does break away from the norm or traditional way of making predictions. The illustration below on the left shows the usual way a model is decided, by gathering a bunch of historic data, and normally around 80% of it is used to train a model, and the other 20% is then used as testing, meaning you make predictions on that 20% and compare it to the actual volumes you have. This is done on several models until you are happy with the accuracy, and then you use that model going forward. But it can be a long process, so businesses tend to use the same models for years. But what happens when trends change, or there are change points in data? The model starts to go off piste, so to say, and it becomes less accurate. So this is what my model aims to overcome, by making predictions using numerous models and storing the results and continuously testing these stored predictions against new receipt data to see what is the most accurate prediction model, and then automatically push that model forward as the one to use. That way we know the program is always using the best fitted model. To plan the project, I've created a Gantt chart which lists the tasks I need to complete the project, along with timeframes roughly estimating how long each task will take. So not so long ago I spent a few weeks at ONS, which is the Office of National Statistics, on a data accelerator course. I was able to learn from experienced data scientists about prediction models and gave me ideas of what models I need to learn. The illustration here shows the stage of the project at the end of assignment 1, and as you can see, a lot of tasks were already completed because this is a work-based project and it was already underway. And at the end of assignment 2, I'm happy to say that practically all tasks are complete. I didn't quite get to the staff needed calculation, as I'm still waiting for data from other areas to be delivered. And I also don't think the last task will be completed soon, but rather an ongoing task, because how many models to test is too many. I also discovered that the Cubist model wasn't suited to time series predictions, so I replaced this with another model called Stepwise. Also, from feedback, I had to change my tested measure from RMSE, which is root mean squared area, to a normalized root mean squared area. This means it transforms that RMSE score to a value between 0 and 1, as it makes more sense to users. The feedback I generally had from the RMSE score was that it wasn't understood, Other data analysts on my team didn't understand what it meant because it was hard to picture a maximum and minimum error score, so the normalized root mean square error makes more sense. The entire project has been created in the R programming language, which is an industry standard open source technology. And because this project is mainly a programming driven one, the bulk of it is purely code, so it's not exactly pretty to look at, but it's the quality of the output that these models predict that is key to the project's success. Saying that though, an output is given, so a user-friendly dashboard has been created to display the outcomes. DVLA uses Microsoft Power BI as its standard reporting tool, so I've made use of this software to display results. So the idea itself is quite complex and has a lot of moving parts, so I've tried my best to document the process in the form of a flowchart. The flowchart is split into 4 main areas: data preparation, model prediction, model testing, and output. I'll now go through each one of these stages in a bit more detail now, starting with the data preparation. An automated data collection process has been set up. The internal DVLA data systems capture the data receipt values at a transactional level, and these get stored in an Excel spreadsheet via a manipulation process which reads and transforms the original system SQL database data into a correct shape and format that can be used in R. In the program itself, the only manual interaction the user deals with is to tell the program how far in the future to predict and what test period to use. A sample of an input is shown here. So once the user has input the variables, the code then reads the Excel sheet to filter the test and training datasets based on these parameters and carries on into the process unsupervised. The data collection process itself was a bit of a learning curve, as I got to learn about regressors. So a regressor is basically a unique characteristic about the receipt date, so the model can learn about the dates and look for similarities going forward. Below is a sample of the stored receipt data, and here you can see the regressors in the green columns and the receipt values in the orange columns. So the amount of regressors to use can be unlimited, so I've set up my data this way so I can add more in the future if I need to. And it's basically these regressors about a future date that are fed to the prediction model, so we can look for in the training data similarities on historic data. Each model then receives the same training and test datasets which contain these regressors, and predictions are made by each model for the period the user stated in the data preparation stage. These predicted volumes then are stored for future testing. Again, I have learnt a lot of new coding skills here around data preparation and how to code different prediction models, and also the science behind each model, which is also equally important. These are some of the code snippets of the random forest and profit models. As I said earlier, the program is all code and the output is simple, but it's the quality of the data that is important in prediction processes. This data is output in a simple table which is easily read by Power BI for clear reporting. The testing process for prediction models starts from the beginning, immediately after the user states the test period. The program creates test datasets from the actual receipt data and from the previous predictions stored for each of the models. Once these both datasets have been retrieved, the program then calculates the NMRC score for each and provides results in a small table, where the lower the score, the better the model performed. To ensure the program is pushing the correct model forward, manual inspections of the raw data were performed. The first table here is an example showing the NMRC score for manual renewal transactions. And as you can see, the Random Forest 1 models performed the best for this particular transaction with a score of 0.38. The second table shows the official prediction results, and as you can see, the Random Forest 1 has been used for manual renewals. Also, you can see from the table that different models have been used for the turnaround renewal and medical renewal transactions, as the seasonal REMA and stepwise 2 models perform better for these particular transactions. Once this output table has been formed within the program, the code then exports the official results to an Excel spreadsheet so it can be read through Power BI. This makes it easier to show predictions and how accurate the predictions actually are in a user-friendly format. So the Power BI report is very basic at the moment, but I will gain feedback from end users to discover exact requirements. But as you can see, the report itself is interactive where the user can select what week they want to see by transaction to view predicted and actual values and then see how far out the predictions were. They can also select dates to see the predictions of next week. A chart is also here to aid visualization of the days of the week, and I'm happy to see that the models have learnt the seasonality of the week and are pretty accurate with their predictions. But with machine learning programs, the more data is fed, the more accurate results will be. So I'm now hoping this will convince DVLA managers the need for data science and how it can benefit the agency going forward. Looking back on the project, I admit I have enjoyed it a lot. I have progressed my coding skills further and now understand how regressors work in prediction processes and how prediction models operate. It also gave me a gentle reminder, not everyone is like me. Raw data needs to be simplified so a wide audience can understand what it's actually saying. Also, the Japan 5.0 project, which I learned about in Assignment 1, of using artificial intelligence in everyday things, has stood out to me and I believe it's the future. It has given me further ideas of how AI can be used at the DVLA, and with the new skills I have learnt, this will put me in a good position to drive this forward and reduce operating costs, saving taxpayer money. I believe this project is the start of something good. Hopefully it will be used in an official capacity, as I believe it can reduce the operating costs of not employing additional seasonal staff. It can also save manual resource of forecasting. At the moment, several staff within operation areas carry out forecasting exercises, so this model will free up their time so they can find other tasks that need doing. I say let the computer do the predicting, as they are more efficient and quicker than humans are doing it. Here is a list of references that helped me with this project. They mainly read in the official package manuals to see how the models would accept data and formats. And although I do have a lot of experience using R, a lot of prior knowledge has been used here. I have to give many thanks to the data scientists situated at ONS for helping me with advice on what types of prediction models to use. So this concludes the video presentation. I hope you enjoyed, and I apologise if it's over 5 minutes. There's actually a lot to go through. Thanks a lot.